Okay, this is my first attempt to do a problem on the board to maybe show everyone a little bit better how these problems can be done in the epidemiology part of our course. And I wanted to look at another food poisoning example since they're so popular in public health. Here's an example of an outbreak of salmonella on a cruise ship. All right, salmonella. So there was an outbreak and the investigators conducted a retrospective cohort study which is kind of interesting. Cohort meaning a group of people chosen because of their exposure. Okay, chosen for the exposure. They were all on the cruise ship. They must have eaten there. They were exposed to the salmonella. It's a closed environment, so I would assume that everybody was chosen. And then, because they were chosen because of their exposure, that makes it a cohort study. But then the illness had already happened also. Both the illness, the exposure, and the eating all happened in the past, and they got sick from it in the past. It all happened in the past, so we're choosing them for the exposure and retrospectively going into the past to see what the outcomes were, who got sick from what. Okay, so they found that 60 had symptoms consistent with salmonella. I'll just say sick. They had the salmonella. And of course, the standard CDC procedure, outbreak investigation, you suspect food. So you go through food questionnaires and ask everybody what did they eat, when did they eat it, what was on it. So one of the questions was whether they ate the tomatoes from the salad bar. So they came up with, I guess, 130 people ate tomatoes. And out of that 130, 41 got sick. And then that left 170 did not eat the tomatoes. And out of that group, 19 got sick. So now we could make a table. We have all the numbers we need to make a table. Let me see whether you can actually see the whole table. Yes. Okay, it's looking all right. So we have exposures and we have the illness. Yes, no, and tomatoes, no tomatoes. And we'll have our totals. Okay, so it was 100 tomatoes, 130 ate tomatoes, 41 sick. So how many were not sick? We can subtract. 10 minus 1 is 9. 12 minus 4 is 8. We had 170 did not, and that was a total of 300. 19 got sick, so what does that leave? 151. Then we total these. So that's our 60 who were sick. And here is the 240. Okay, so there's our table. Let me make sure that I got the whole table in here. All right, so we got the whole table. I just don't have a lot of room to do much else here. So I'm going to erase the top. Okay, so now I'll use the top. Red, for some reason, seems to be a good color to show up on the camera. All right, so now let's go to our sheet, our worksheet on chapter 3, where we have that blank table that you can make at the top. And what is it that we're typically asked? First question, what is the, and this will be a cumulative incidence rate among the exposed. Okay, the exposed are those who ate the tomatoes. Okay, so we have number of new cases. Of course, they're all new cases over the total at risk. We know that anybody can get salmonella poisoning. Nobody had it before they went on the cruise ship, so they're all at risk. So we've got 41 out of 130. Okay, sorry, left it in the other room. So 41 divided by 130 gives us 0.315. You can express that however you want. You can say it's 31.5 per 100 or percent of the ones who, a cumulative incidence is a proportion, so it's appropriate. You can express it as a percent. So almost a third, which would have been 33%, almost a third of the tomato eaters got the salmonella. And then the next question in our list is, what is the cumulative incidence in the unexposed? So that would be the ones who didn't eat the tomatoes. So same thing, new cases over those at risk, which is everybody. So we have 19 over 170. So 19 divided by 170. So we have 0.112 or 11.2%. So you can see already quite a difference in the rates at which people who ate tomatoes got sick compared to those who did not eat tomatoes. And of course our third question gets directly at the relative measure of comparing here. The relative measure meaning the ratio, risk ratio, or RR, which is the rate in the exposed divided by the rate in the unexposed. So we just use the numbers we came up with here. Just use you can use either of these forms, but make sure you use the same ones. If you're going to use the decimal form of the exposed one, use the decimal form. You would get the same answer if you put 31.5 over 11.2. It would just be, it would come out to exactly the same number. So 0.315 divided by 0.112 is 2.8125. We'll just settle for the 2.8. Okay, now we should definitely give a sentence here explaining what does that mean. It means people who ate tomatoes were 2.8 times as likely to get salmonella as those who did not eat the tomatoes. Now let's see if I've written completely off the screen. No, not really. Okay. So I hope that's ending up to be legible. That is the first three questions on that standard worksheet for Chapter 3 that you have, that you can just assume that I'm going to give a problem like this on the midterm, and I'll pick 2 or 3 of these to ask you about. So let me erase this.